This is a part third video about collection of similarity or preferences data. This is a part of multidimensional scaling. As already noted that primarily distinctions among the multidimensional scaling program is the type of the input data matrix versus non-matrix, or whether the data represents similarities or preferences. Here we address issues associated with making the similarities based on preferences judgments. For many of data collection methods, either matrix or non-matrix data may be collected. In some instances, however, the respondents are limited to only one type of data. Similarities data. When collecting similarities data, the researcher is trying to determine which items are the most similar to each and other which are the most dissimilar. The term of similarities and dissimilarities often are used to interchangeable to represent measurement and differences between the objective input, and the similarity measurement is the ability to compare all pairs of objects. If, for example, all pairs of the objects of the set A, B, C, that is AB, AC, and AC, re-rank ordered, then all pair of objects also compared. Assume that the pair were ranked AB is equal to 1, AC 2, and BC 3, where 1 denote most similar. Clarity pair AB is the more similar than AC pair AB is the more similar than pair BC, and pair AC is more similar than pair BC. Several procedures are commonly used to obtain respondent perceptions of the similarities among the situation. Each procedure is based on the notions that relative differences between the pair of the stimulate must be measured so that the research can determine whether the pair is more or less similar to any other pair. We discussed three procedures commonly used to obtain the respondent perceptions of the similarities: compare of paired objective, confused data, and derived measures. Comparison of paired objective. By and most widely used method of obtaining similarities judgments in that paired objective, in which the respondent is asked simply to rank or rate the similarities of all pairs and objective. If the estimated A, B, C, D, and E, we could rank pairs AB, AC, and AD. These are most dissimilar to least similar. If, for example, pair AB is gained to rank 1, we would assume that the respondent sees that the pair of containing the two stimulate that are most dissimilar in contrast to all the other pairs seen example in preceding section. The procedure provides a non-metric measurement of similarities. Metric measurement of similar would involve the rating similarities. For example, the very similar 10, not all similar. Either the from metric and non-metric can be used. Most multidimensional scaling program. Confused data, measuring the similarities by pairing of confused stimulate with the stimulate is known as the confusion data, also known as subjective clustering. A typical procedure to gathering these data when the number of objectives is large is as follows. Place the objective whose similarities is to measure on small card, either the descriptively or with the pictures. The respondent is asked to sort the card into the stakes so that the all card in a stake represent the similar candy bars. Some researchers tell the respondent to sort into the fixed number of the snacks. Others says to sort into many snacks as the respondent wants. The data from each respondent is the aggregate into the similarities matrix, similar to across the tabulation table. Each cell contains the number of time each pair of objective was included in the same stack. These data then indicate which product compared together most often and are therefore considered the most dissimilar. Collection data in this manner allow only for the calculation of aggregate similarities because the respondent from all individuals are combined to obtain the similarities matrix. Drive measurement similarity based on score given to stimulate by respondent are known as drive measures. The researcher defined the dimension attributes and the respondent rate. Each objective of each dimensions from these rating, the similarities of each objective is calculated by such method as the correlation between objective or sum of index of agreement. For example, subjects are asked to evaluate three stimulate strawberry and the lemon lime soda on a number of attributes: diet versus non-diet, sweet versus and light tasting versus heavily tasting. Using the semantic differences scale, this respondent would be evaluated for each respondent, for example, correlation or index or agreement. To create similarities measurement between the objective, three important assumptions underline this approach. The researchers select the appropriate dimension to measure. The scale can be weighted either equally or unequally to achieve the similarities data for the subjective of group of subject. All individuals have the same weight of the three procedures discussed. The drive measurement in the least desirable, meeting the spirit of multidimensional scaling, that the evaluation of objective be made within the minimum influence by the researcher. Preferences data implies that stimulate should be judged in terms of the dominance relationship, that is the stimuli are ordered in the term of the preferences or the one properly. It enables the researcher to make the direct statement of which it is more preferred objective, that is a brand preferred over brand. The two most common procedure for obtaining preferencing data, the direct ranking and the paired comparison. Direct ranking, each respondent rank that object from the more preferred to least preferred. This method of gathering non-matrix similarities data is a popular basis. It is easy to administer for the small of the moderate number of objectives. It is a quite similar concept to the subjective cluster program and discussed earlier. Only this case of object must give a unique rank. Paired comparison. A respondent is presented with all position pair and asked to the indicate with the member of each pair is preferred. Then overall preference is based on the total number of time each objective was the preferred number of the paired comparison. In this way, the researcher gathered the explicit data from each comparison. The approach is overall all the possible combination and is more detailed than just direct ranking. The principal drawback to the method is that large number of tasks involved with even the relatively small number of objects. For example, 10 objects result in 45 paired comparison, which are too many tasks for more research solution. Note that paired comparison are also used to collecting the similarity data. As also noted that the example at the beginning of the chapter, but there are also used in collecting the similarity data as noted in the example in beginning that the chapter, but there are pair of objective and rank related as the degree of similarities between the two objective in this pair. Preferences data versus similarities data. Both similarities and preferences data provide a basic constructions and perpetual map that can depict the relative position and the objective across the perceived interface dimensions. Selecting between the two approaches lies the objective to be. Similarities based perpetual mapping are best suited to understanding the multi attribute dimensions that describe the objective. In this approach, the focus is on characterize the nature each objective and its decomposition relative on other objects. Preference data enable the researcher to review the location of objects on the perpetual map for which distance implies differences in preference. This procedure is useful because an individual perception of objective is in preference context may be different from the in the similarities context. That is, the particular dimension may be useful in describing the dissimilarities between the two objectives but may not be consequential in determining preferences. And the differences basis for comparison in the two approaches many times result in a quite different perpetual map. Two objects could be perceived as different in the similarity basis map but be similar in the preferences based of spiral and map, resulting in two quite differences map. For example, two differences brand and candy bars could be far apart in the similarities basis map, but the equivalent preferences be positions close to each other and the preferences map. The researcher must choose the map that best matches the objective of the analysis. Thumb rule 2, research design of the multidimensional scaling perpetual map can be generated through the decompositional or the compositional approaches. Decompositional approaches are the traditional and the most common method, requiring only the overall comparison of the similarities between the objective. Decompositional approaches are used when the research objective involve comparison but on the defined set of attributes. The number of objectives to be evaluated is a trade-off between a small number of objectives to facilitate the respondent task, 4 times as many objects as dimensions desired, the 5 objective, 1 dimensions, 9 objective, 2 dimensions, and obtain thus stable solution. Here we talk about the stage 3, assumptions of multidimensional scaling analysis. Multidimensional scaling analysis has no restraining assumptions on the methodology, type of data, or from the relationship among the variable. But multidimensional scaling does require the research accept 3 tests concerning perceptions. Variations in dimensionality. Respondent may vary in the dimensionality they use to for their perceptions or an although it is the throw that most people judge in terms of a limited number of characteristics of the dimension. For example, some might evaluate a car in terms of the horsepower and appearances, where others do not consider this factor at all but instead assess it is the term to cost and interior comfort. Variation and respondent need to be attached the same level of importance to a dimensions, and even if all the respondent perceive the dimensions, for example, two respondent perceived a soft drink in terms of its level of carbonation, but one many consider this dimension uniport, whereas the other may consider it very important. Variation over time, judgment of the stimulus in terms of either the dimension of level of importance and likely to change over the time. In other words, one may not expect respondent to maintain the same perceptions for the long period of the time. In spite of the differences we can expect between the individual multidimensional scaling methods can represent perceptions spatially, so that all of these differences across the individual are recommended. This capability enables multidimensional scaling technique to not only help a researcher understand each separate individual but also to identify the shared perceptions and evaluating dimension within the sample of respondent. Stage 4, driving the most solution and assessing the overall fit. Today, the basic or multidimensional scaling program available in the major statistical program can accommodate the difference in the type of input data and the type of the spatial representation, as well as the varying the interpretational alternatives. Our objective here is provide an overview of multidimensional scaling to enable already understanding of the differences among these programs. However, as we other multivariate technique development in both application and knowledge is continual. These we refer that user interested in a specified program application to other texts devote slowly to multidimensional scaling, determining an object position in the perpetual map. The first task of the stage 4 involve the positioning of the object be best reflect the similarities evaluation provided by the respondent. See figure 5 here. The multidimensional technique discriminate the optimal locations for each object in a specified dimensionality. The solution for each dimensionality is 2 dimensions, 3 dimensions, etc. are then compared to the select the final solution, defining the number of dimensions and each of objective relative position and those dimensions. Creating the perpetual map. Multidimensional scaling program follow a common 3-step process to determining the optimal position in a selected dimensionality. Number 1, select an initial configuration of the stimuli. At the desired initial dimensions, various options for obtaining the initial configuration are available. The two most widely used are configuration either applied by the researcher based on previous data generated by the selecting pre-derived points for the approximately normal multivariate distribution. Compute the distances between the points and comparable, the relationship observed versus the drive with the measurement fit once the configurations is found in the interpoint distances between the stimulate. These starting configuration are comparable with the distances measurement derived from the similarities judgment. The two distance measurement are then compared by the measures by fit typically measures stress width measurement are discussed in a later section. If the measures of fit does not meet a selected predefined stopping values point a new configurations for which the measurement of fit is further minimized. The program discriminate the directions in which the best improvement in fit to be obtained to the move the point in the configurate in those direction in the small in in increments. The need to be computer program versus had calculated become the apparent of the number of objective and dimensional increases. Let us look the typically multidimensional scaling analysis and see the what is actually involved. With 10 product to be evaluated, each respondent must rank all 45 possible pair of objective from the similar to the similar. With these rank order, we proceed attempt to define the dimensional and position of each project. First, assume that we are starting with the two-dimensional solution. Although we could define any number of dimensions, it is easiest to visualize. The process is a simple two-dimensional situations. 10 points representing the 10 points product randomly can be select of the graph paper representing the two dimension and the measures the distance between the every pair of points 45 distances. Calculate the goodness of fit of the solution by measuring the rank or order agreement between the Euclidean strength line distances of the plotted objective and original 45 rank. If the strength line distance do not agree with the original rank, move to 10 point. Try to again continue to move the objective until get satisfactory fit among the distances between the objective and the rank, indicating similarities. You can then point the 10 object in 3-dimensional spaces and follow the same process. If the fit of actual distances are similarities, rank is better than the 3-dimensional solution may be more appropriate. As you can see, the process quickly become the interactable with the increase in the number of the objective and dimension. Computer excluded the calculation and follow the more accurate and detailed solution. The program calculated the best solution across any number of dimensions, those the providing the basic of compare the versus solution. This primarily criteria in all instances the finding the best presentations of the data is preservations of the ordered relationship between the original and the data the drive distances between the point. Any measures of the fit is simply measurement how well the rank based on distances on the map agree with the rank given by the respondent. This is the from stage 3 and stage 4. Selecting the basic from the perpetual map. Does the map represent the perpetual of the similarities of the preferences? If it represent the similarities, then the based perpetual map. Similarities based perpetual map. Relative position or objective reflect similarities and perceived dimensions. Preferences based perpetual map. Preference reflected by the position and object versus ideal points in earn analysis and perpetual map with the ideal point of strictly from the preferences data using these softwares. Estimated then perpetual map input aggregated and disaggregate data in these similarities. The input, these are the inputs, and after that selecting the dimensionalities of the perception map versus second spectrum star measures and index fit. Here is the internal analysis estimated the perpetual map and ideal point of strictly from the preference data and using this software. External analysis tab 1 estimate the similarities based on perpetual map and second position idea points on the perpetual map with pre-map. Here is a stage 5. Then in this stage 5, identify the dimensions, subjective procedure and objective procedure. Stage 6, validating the perpetual map, use of the split of multi-samples, convergence of the decompositional and compositional results. Stage 5, multidimensional scaling, detailed solution. The program calculates the best solution across any number of the dimension. Those provide a basic to compare the various solution. The primary criteria in all the instances for finding the best interpretation of the data is preservation. In order to relationship between the original ranked data and the derived distance between the point. Any measurement of the fit, for example stress, is similarities a measure how well or poorly the rank based on distances on the map agree with the rank given by the respondent. Avoiding disagreement solution. Disagree. Avoiding degrenate solution. In evaluating a perpetual map, the researchers should always be aware of de- degenerate solution. Degenerate solution are derived perpetual map that are not accurate representations of the similarities responses. Most often they are caused by the inconsciousness in the data and the inability of the multidimensional scaling program of each a stable solution. They are characterized most often by either the circular pattern in which all objects are shown by the equally similar, or the clustered solution in which the objects are grouped at two ends of the single dimension. In both cases, multidimensional is unable to differences among the object, and some they are uh, research should be the maximizing the research design and where the inconsistency occurs. Selecting the dimensionality of the perpetual map. As seen as the previous series, multidimensional defined the optimal perpetual map in the number of the solution of varying the dimensionality. With this solution in hand, an objective of the next step is the selection of the spatial configuration. Perpetual map is a specified number of the dimension that determine how many dimensions are actually represent in any data and reached through, and there are approaches objective evaluation 3 plot and the measures is our overall index fit. Subjective evaluation, the spatial map is order starting the point of the evaluation. The number of the map necessary for interpretation depend on the number of dimension. A map is product for each combination of dimension. One objective of the research should be obtain best fit of the smallest possible number of the dimension. Interpretation and solution drive in more than 3 dimension is extremely difficult and usually is not worth the improvement in fit. The research typically make a subjective evaluation and perpetual map and determine whether the configuration looks responsible. This evaluation important because at least the stage of dimension will need to be interpreted and explained. Stress measures. A second approach is to use a stress measure which indicate that proportions of the variance of the disparities, differences in distances between the objective of the perpetual map and the similarities judgment of the respondent and not accounted by the multidimensional scaling model. The measurement varies according to the type of the program and data being analyzed. Stress in the most commonly and measured the determining the model of the fit defined by the stress is equal to these are the formula: average distances on the map and drive distances. Perpetual map originate distances based on the similarity judgment. These stress values become similar as the derived approaches. The original dij stress is minimized when the objective are placed in the configuration so that the distances between the objective best match the original distances. A problem found in using the stress, however, in analog that R2 is a multiple regression that stress always the improve with the increase the dimension. Remember the R2 always increase with the additional variable. A trade must be then made between the fit and solution that the number of dimension as was done for the extractions of the factor and factor analysis. We can plot the stress available against the number of the dimension and determine the best number of the dimension utilized is to be analyzed. For example, is the screen plot in figure 6, the elbow indicate that substantial improvement in that goodness of fit when the number of dimensions is increased from 1 to 2. Therefore, the best fit is obtained with a relatively low number of the dimension. Index of fit, a square correlation index, sometimes used to as an index fit, it can be interpreted as indicating the proportion of variance of the disparities accounted for the MDS procedure. In other words, it is measured how well the raw data fit the multidimensional model. The R2 measure in multidimensional scaling represents essentially the same measurement of variance as it does in other multivariate techniques. Therefore, it is possible to use the similarity measurement and criteria that the measurement of 0.60 of better are considered conceptual, and the higher that are to the better the fit, incorporating the preferences into multidimensional scaling. Up to the points we concentrated on development perpetual map based on the similarities judgment. However, perpetual map can be also derived from the preferences. The objective of the determine the preferences mix and the characteristic of the set stimulate that the predict that preferences given the set of configuration and objective. In doing so, on joint space and develop the portray both of the objective and the subjective idea points. A critical assumption is the homogeneity of the perceptions across the individual for the set of the objective. The homogeneities enable the differences to be attributed to the preference, not the perpetual differences. Ideal point. The term ideal point has been misunderstood of the mislanding at time. We can assume that if we allocate on the drive perpetual map the point that represent the most preferences combination of perceived attributes, we have identified that the position of an ideal objective equally. We can assume that the position of this ideal point relative or the object product on this drive perpetual map define relative preferences so that the product further from the ideals should be less preferred than the ideal point of position so that the distance from the ideal convey the change of interfaces. This is the use of the screen plot and determine the appropriate dimensionalities. Here is the stress, here is the number of dimension, this is decreasing. Multidimensional scaling dimension, second one. So in short, if we talk about, like, if we define it's in a very simple word, so multidimensional scaling is that scaling where we calculate dimension in many point of view. Suppose dimension 1, dimension multiple dimension, we can say, indicate respondent endpoints. A respondent model plots with the perpetual map. Consider we example figure 7 when the preferences data in 6 candy bar A and F obtained from the random, there are point indicate that dot was position that increasing the distance from the indicate that defining the preference based on the perpetual map. This respondent preferences is CFDEB, CFDBEA, to imply that ideal candidate bar is exactly that point or even beyond. In this direction shown by their this line from the original can be misleading. The ideal point simply define the order preference relationship most preferred to least prefers among the 6 candy bars that respondent. Although ideal points individually may not offer the insight cluster and them can be useful in defining the segment, may are prudent with ideal point in the same journal areas represent the potential market agreement and person with the similarity preference are indicated in figure 8. Here is a determining a points. Two approaches generally work and determine ideal point explicitly and implicitly emissions. The primary differences between the two approaches is that the type of evaluation response is requested of the respondent. We discussed each approaches in the following section. Explicitly estimations. Explicitly estimation procedure from the direct respondent and object, typically asking the subject to rate an hypothetical ideal or the same attribute in which the other stimulated are rated. A term, a respondent is asked is an including among the stimulate used in the similarities data and hypothetical ideal situation. When the asking the respondent and conceptual ideals analyzing, we typically run into the problem. Often the respondent conceptual and ideals at the extreme of the explicit rating use the being the similar to the most preferred product from the among the those which are respondent that has experienced. Also the respondent must link in term of the similarities but preferences, which is the difficult with relatively known as objective. This perpetual problem lead to be research to be implicate ideal point of estimation. Implicit estimation several procedure to implicit positions ideal points and describe in this following section. These assumptions underline most procedure is that driving measurement of ideal point spatial position are maximized consistent with individual respondent preferences. These are the multidimensional scaling. Here is these are the incorporate multivariate ideal one points of the perpetual map. Srinivasan and scholar assume that the ideal point for all pair of stimulate is determined so that the violates that least arm of constraint that is the closer and most preferred each pair that is the least preferred. Summary: ideal point estimate can be approached in many ways and no single method has been demonstrated is be best in cases the choice dependent and researcher skill and multidimensional procedure selection. This is the implication positioning of the ideal point. Implicate position and ideal point from the preferences data can be accomplished through the either an internal and external analysis. Internal analysis preference data preference to the development of the spatial map shared by the both stimulate and subject points or vectors slowly from the preferences data. External analysis preferences use of the specified configuration and objective and the attempt place the ideal point of within the perpetual map. Each approaches are advantages and disadvantages which are discussed with the following section. Internal analysis must certain assumption is driving a combination perpetual map of the stimular and ideal point, the objective position and calculating based on unfold preferences data. Each individual the results reflect perpetual dimensions that are stressed and weighted the predict preferences on the characteristic of the internal estimation method that they typically employed a water representation on the ideal point. See the following section for the discussion of the vector versus point representation where the external method can be estimated either the vector or the point representation. As an example of this approach, two or more widely used programs unable to ensure that configuration or similar ideas point in doing so on research must assume that following: no differences between the respondents, separate configuration for each respondent, a single configuration with individual ideal points. By gathering the preferences data, the researcher can represent both stimulate and respondent on a single perpetual map. External analysis preference data prefer to the fitting ideal point based on the preference data to stimulate the space developed from the similarities data obtained from the assumed subsection. For example, we might scale similarities data individual, examine that individual map for commonalities of the perpetual and the scale that preferences data for any group identified is any flash functions. If the procedure is followed by the researcher must gather both preferences or similarities data to achieve the external analysis. PREFMAP were developed slowly to perform the external analysis to preferences data. We ensure the similarities matrix define the object to the perpetual map. The researcher can now define both attribute description, assuming that the perpetual space is the same as the evaluating dimensional idea point of the individual. PREFMAP provide the estimated for the number of differences type of the ideal points. Each of base differences assumptions as to be ensure the nature of the preferences. For example, versus point representation of equal versus differences dimensional weighted. Closing the between the internal and external analysis, it is generally accepted that external analysis is clearly preferred to the internal analysis. This conclusion is based on the conceptual difficulties with external analysis procedure, and one of the confounding and differences in a preferences with the differences in a perceptions. In additional that the silences or perceived dimensions may change one move from the conceptual space as our stimulate similar and discriminate to evaluate the space which stimulates is preferred. As discussed, the procedure of external estimate in our example and perpetual mapping with MDS end of this chapter. Point versus vector presentations. And this topic I will talk about for next video.